All right, sorry guys, not sure what that alarm was for, but I couldn't figure out how to shut it off without turning off my YouTube video. So continuing on, we were working on the initial value problem, the derivative of y plus the function 1 over x times the function y equals the sine of x, already in perfect form for us. Nice, beautiful, easy, simple integrating factor here of just x. So we're going to go back to our problem in its perfect form, and we're going to multiply both sides by x. So I get x, y prime, plus, well, x times 1 over x is just 1 times y equals x, the sine of x. Now, if you notice, the first function is x, here's its derivative. Here's the function y, here's its derivative. So this condenses nicely into x times y prime equals x sine of x. Once it's in this form, we are going to take the integral of both sides. Right, so the antiderivative of a derivative is just that. All right, so now here, this brings us back to chapter 7 and taking the antiderivative of x times the sine of x. So the trick is to use parts. Let u be x and dv be sine x, and go with that. And I'm going to let you fill in the details. If you're having a problem, by all means, zoom in. We can talk about it. But hopefully at this point, we're really good at it. The antiderivative of x times the sine of x is negative x cosine x plus the sine of x. And our arbitrary constant is going to live over here on the right side of the equation. All right, so now let's keep going with this. We want to solve for y, so I'm going to divide out both sides by x. So I have to divide everything by x. So negative x cosine x divided by x will just be the negative cosine of x, plus nothing to cancel here, so it's just going to be the sine of x over x. Don't forget this constant, it's really important, c over x. So this is the general form of the solution to our initial value problem. We have to go back and remember where this stemmed from. Here's our problem. We're told when the input is pi, the output is 1. So we're going to say when the input is pi, negative cosine of pi plus the sine of pi over pi plus c over pi, the output's going to be 1. So let's just do this here. Cosine of pi is negative 1, so negative 1 is positive 1. Sine of pi is 0, so this term goes away, plus c over pi equals 1. Let's do that. So here we can see that c has to be 0. Subtract 1 from both sides, and only 0 divided by pi would give us 0. So therefore, my particular solution is going to be negative cosine of x plus sine x over x, and that's it. This goes away. So that is the particular solution to the initial value problem that we were presented with. All right, I have one more for you, and I liked this one because I loved the complexity of the integration. So let's look at this initial value problem. Cosine of x times y prime plus the sine of x times y equals 2 cosine cubed sine x minus 1. It's an initial value problem, so we know we're not going to leave a c in our final answer. So let's write this guy down, cosine of x, and we'll worry about the initial conditions later, keeping in mind we're only working between 0 and pi. Sine x minus 1. All right, so here's my right-hand side. Right now we got to get it into the form, the derivative of y plus some function of x times y, blah, blah, blah. So we have to get rid of this cosine. So we're going to divide both sides by the cosine of x, the whole left side and the whole right side. And now it's in the form that we can work with it. Sine of x plus over the cosine of x times y equals, well, we have 3 cosines here and 1 here, so this just becomes 2 cosines squared of x times the sine of x minus 1 over the cosine of x. I'm going to clean this up a little bit. Sine over cosine is just the tangent, so we're going to have y prime plus the tangent of x times y is equal to I can't do much here. 2 cosine squared of x, sine of x, minus, I'm going to just call this the secant of x for now. Looks nicer. All right, so now we have it in the perfect form. We have y prime by itself plus some function of x times y, and then the whole thing on the right-hand side is just a function of x. So now we need to find our integrating factor, and it's e, the integral of the function here, so tangent of x dx, which is e to the, well, the antiderivative of the tangent is the natural log of the secant, and we can eliminate the absolute value bars because the secant is positive between 0 and pi over 2. So my integrating factor works out nicely to just be the secant. So remember, this is the form that we want to multiply both sides by the secant. We may not do it up here in the original. It won't work. So I'm going to take the secant, multiply it by both sides of this linear first order differential equation in the proper form. We get the secant of x times y. Here, I'm going to do this. Prime plus the secant of x times the tangent of x, all times y, equals, oh, yuck, 2 cosine, I'm going to write it down here, 2 cosine squared x, sine of x, times the secant of x, right, minus, well, the secant times the secant will be the secant squared of x. All right, looks terrible, but this works out pretty nicely. So let's work with what we have here. All right, so notice on the left-hand side, we have the secant, and then we have the derivative of the secant. We have the function y and its derivative. So the left side condenses nicely to the secant of x times y and its derivative. Let's clean up the right-hand side. Notice the secant is 1 over the cosine, so actually that cancels out with one of those cosines. So a cosine times a secant cancel each other out. This just becomes 2 cosine of x, sine of x, minus the secant squared of x. All right, not too terrible. Now we're going to integrate. We are going to take the antiderivative of the secant of x times y, and we're going to integrate 2 cosine of x, sine of x, minus the secant squared of x. All right. Whoops, I lost the derivative here. Don't do that. So the integral of a derivative is just the integrand, secant of x times y. All right, now here we have to integrate these two. We know the antiderivative of the secant squared is just the tangent, so we need to find the antiderivative of 2 cosine times the sine. Well, I'm going to tell you that it's just the sine squared, because the derivative of the sine squared is where we bring the 2 out front and leave what's inside alone, take the derivative of what's inside. So you can use u substitution here. And then the derivative of the secant is the secant squared is the tangent, plus my arbitrary constant. So we have the secant of y, the secant of x times the unknown function y equals sine squared of x minus the tangent of x plus c. Now we can solve for y by dividing the secant out. Sine squared of x all over the secant of x minus the tangent of x all over the secant of x plus the constant all over the secant. Don't lose that guy. We can clean this up a little bit. 1 over the secant is just the cosine, so this is just the sine squared of x times the cosine of x. This isn't incorrect, this is just more visually pleasing, and I'd rather stick pi over 4 into this than into the fraction. And then the tangent over the secant, well, the tangent sine over cosine, this is 1 over the cosine, so the tangent over the secant is just the sine of x. And then the secant in the denominator is equal to the cosine in the numerator. So I just think that's more visually pleasing. This isn't incorrect. This is just simplified and more visually pleasing. So there's your general solution because we have this arbitrary constant c sitting in there. I'm going to stick in pi over 4, and the output needs to be 3 square root of 2. So at pi over 4, we get sine squared of pi over 4 times the cosine of pi over 4 minus the sine of pi over 4 plus c cosine pi over 4, and that all needs to equal 3 square root of 2. And this does work out nicely. Sine of pi over 4 is square root of 2 over 2. Squared is going to be 1/2. Cosine of pi over 4 is the square root of 2 over 2. Minus sine of pi over 4, which is the square root of 2 over 2. Plus c times the cosine of pi over 4, which is square root of 2 over 2, equals 3 square root of 2. And we're going to get that c equals 7. So I'll let you do the algebra there. And then we'll get the particular solution, y equals sine squared x cosine of x minus the sine of x plus 7 cosine of x. Again, you can always check this back into the original. And that wraps up our differential equations for Calc 2. So to do, read 9.5, exercises 1 to 19 odd. The more you do, the better you will get. 23 and 25. All right, guys. See ya in our section on parametric and polar equations.